Okay, let's look at the homework 5.1, number 9. All right, so we have, let's see, s double prime, so that's the acceleration. So a of t is given to be, so that's the acceleration, s double prime is equal to negative 32. Right? So if you want to find the velocity, which is same thing as s single prime of t, so in other words, acceleration is the derivative of the velocity. So in order to find the velocity, we can just take the antiderivative of negative 32 with respect to t, right? So we can see that this is going to be negative 32 t, right, plus some constant, let's call it v0, right? So that's the initial velocity. All right, so we're looking for with what initial velocity? Actually, this is what we're looking for. So we are trying to find v0. All right, so we need to leave it at that. All right, then we want to find, let's see, since we have to talk about the height of the national monument, so which is national monument, which is 570 feet. So a height function, so s is going to be antiderivative of the velocity. So we take the antiderivative of negative 32 t plus v0 with respect to t. All right, so you can see that this is going to be negative 32 is just a constant. Derivative of t is antiderivative of t is t squared over 2, and then antiderivative v0 is v0t. Then you have initial position, so I'm going to call it some constant s0, right? And it says that, let's say, an object is thrown upward from the ground, so which means that the s of 0 is 0 anyway. So here, this guy is actually 0. All right, so we know that s of t has this formula. So clean up a bit, the 2 and the 32 cancel out, 16. So it's going to be negative 16 t squared plus v0t, right? So that's that. Then what we want to do is we want to make sure that this would reach 570, all right? So upward, then the ground reach the height of the national monument. Okay, all right. So the highest point is gonna happen when the velocity is 0. So we can just set that equal to 0, which we'll find it's going to be just that t is equal to v0 over 32, right? So plug it in. So s of v0 over 32, so that's the highest point, is going to be negative 16. Then you have a v0 squared and over 32 squared. So I'm going to write 32 times 32 because we can cancel 16 and 32. Then you have 2 here. And a plus v0 times v0 over 32, right? So if you clean it up, it's going to be, so it's going to be a negative v0 squared over 2 times 32 is 64 plus v0 squared over 32, right? So this is just a half of v0 squared over 64 is 1/2 of v0 squared over 32. So if you subtract that, you're going to get the half left. So it's going to be v0 squared over 64. All right, and we want this to be, so this is the highest, we want this height to be 570, which is right here. So 570. All right. So this is going to give us. So I'm going to go down here. So we want to find the v0. So v0 square. Multiply both sides by 64. So you're going to get 64 times 570. All right. Then we can just take the square root of both sides. So you get the v0 is equal to. Alright, so we can put plus or minus if you want, but since we're talking about the velocity upward, so I'll just take the positive one and the square root of 64 times 570. Alright, so let's pull out the calculator. Alright, then let's do, let's see, square root. So we have 64 times 570. Get that, then take the square root, right? So it came out to be 190.99. So let's say answer to 2 decimal places. Actually, you can see that 7 rounded up, so 0 rounded up, 0 rounded up, so 191.00. Right? So that's we have 191.00 feet per second. Right? So this is about 191.00, right? Feet per second. Right? That's it. I hope that this was clear.